Here disadvantages is not mentioned. Okay. Then the next is correlation weighted historical simulation. Please note that this is a very complex method. Okay, it has to deal with your part 1. If you see, we had come up with a correlation matrix and other things we had done. We do not have to worry about all of these metrics as of now. Okay, but here what happens is, in we have seen, like in the financial disaster case, we saw that the estimate. Okay, please note that why this company LTCM, we said that the LTCM's models of risk measures, they did not take into incorporation the changes in the correlation, and during time of crisis correlation increases, so your estimates of the VAR, if does not take into consideration the increase in the correlation, you would be underestimating the risk, right? So this is a method which would try to incorporate the correlation and which would increase the these estimate values. Okay, so what we are doing is we are trying to incorporate any increase or decrease in the correlation among between the asset pair. Okay, this method is more complicated than the volatility weighted method, because you need to do more number, as many assets you have to do like NC2 correlation update and then computation. So again, understand the process, no weighted of computation. So what typically is done is, like, you have this matrix, new matrix is being used to do the correlation, the VAR computation. You can compute the VAR. Please note that the VAR can be computed, okay, considering, let's say, the parametric measures only, but your row will change, right? So you can compute the standard deviation of the portfolio, but you have to update with this new correlation, either increase or decrease. As you know that the portfolio VAR or standard deviation can be very well done using the metrics in Excel. That is why you have this matrix method is being used. Okay, so what we say is historical correlation matrix that we had, it needs to be adjusted to incorporate the new correlation. Okay, so we get the returns that we get are actually adjusted with the correlation. Okay, it says that it produces better results than the volatility weighted method, as what happens is you get both the volatility is changed, okay, because and correlation is updated. Okay, so this is the benefit that you have. It is much better than, but please note that it gets a lot complicated than other methods. Okay, the last one of these historical simulation methods, different type, is filtered historical simulation. Okay, it is again complicated, so it is much more complicated than the correlation. Okay, what they are saying is it is a combination of a historical simulation and conditional volatility methods, models, either GARCH or EWMA, whatever you are choosing. Okay, so it is a combination of historical simulation and the models which are trying to predict the new volatility. Okay, so it, as a result, what happens is it tries to incorporate the advantages of both the methods. Okay, so what they are saying is the volatility is forecasted for each day. So each day you will forecast the volatility using some method. Okay, and then you standardize that by dividing with the realized return. So whatever return that you have got, whatever the realized return, you would do that standardization. So the volatility divided by the actual return. Okay, what they are saying is the bootstrapping is done to get the returns which will reflect the current volatility level. So once you have got this, okay, so you will get the, you will do the bootstrapping. So this these returns, okay, are actually bootstrapped, so it will consider the current volatility level. Okay, what they are saying is then where you will get obtained from the simulated values. So whatever you get the actual bootstrapping, and then you will do the simulation, you will take one value, you get the returns, then from there you get the VAR. Okay, one of the advantage of this method is, please note that where we have typically said that if the horizon is lesser, then VAR is a good method. This method can be used, okay, when you want to compute the VAR over long horizon, okay, and you want to do it on a multi-asset portfolio, because you are doing the bootstrapping. Bootstrapping can be, we have seen in the Excel sheet that it can be done on a multi-asset portfolio. Okay, now empirically they have seen that this method also works well. Okay, So this method has worked well and is given like the VAR estimates are or the coherent risk measure estimates are good. Now the next LOS or next aim statement, it wants us to get to know the advantages and the disadvantages of this method. So please note that you have so many advantages and similarly disadvantages of this method. Go through the book, okay, see in detail. I have just like highlighted like most of them, okay, but not in detail. Okay, so what they are saying is these methods are intuitive, okay, and some of the methods are actually computationally simple. Example is historical VAR. It is computationally simple. Okay, it does not take into account any assumption about the parameters, whether it's a normal distribution, skewness is 0, kurtosis is 3. It does not worry about anything. So we are not bothered about whether it's a fat tail, skewed, whatever exactly it is. Okay, it does not consider complex matrices. Okay, so this is another benefit is it does not brings in more complexity. Simple. Okay, one more advantage is the data is readily available. See, in case of Monte Carlo, when you are trying to create the VAR, you will try to get those data through the Monte Carlo simulation. Okay, here you have the data is available. In some of the methods you do not require adjustment. Some of the methods you require adjustment, but on those data which are available, you will not change this data. Okay, you will not do adjustment on this data. Okay, some methods can take more complex approach. Okay, it can accommodate any type of position. Okay, it can accommodate any type of position, long, short. It can accommodate derivatives position also. Okay, it is easy to implement. You can even implement on a spreadsheet, right? We did the bootstrapping. We have just implemented that in the spreadsheet, right? So you can select various things and you will implement on a spreadsheet. Okay, what they are saying is results are easy, okay, because you are computing VAR measures, okay, so which are easy to report to the senior management and communicate. So you will say, okay, this is the loss that we are expected to suffer with this probability. Okay, now what they are saying is you can also produce the confidence interval for the VAR measure and the expected loss. So once you have got the VAR measure, you can create the VAR measures confidence interval by trying to get a standard error. So what you have is a standard error that you will get. This standard error computation would be much more simpler than the parametric method that we saw in the previous chapter. Okay, because you will know, okay, this is the VAR case values, okay, and you know the variability of that. You will be able to create a very good way confidence interval in a very simple approach. Okay, what they are saying is this method is actually can be refined, okay, by combining various non-parametric method, or you can combine this with a parametric approach. Okay, so you can take some assumption about the parametric approach, combine this with the non-parametric method and can get a better result. Okay, these are the advantages. Then let us see what are the various disadvantages of this method. Okay, one of the advantages, if you see readily available data, this is actually becoming its disadvantages. It is actually dependent on the historical data. It is very much dependent on the historical data. Okay, history may repeat, may not repeat in the future. Okay, one thing what happens is the VAR and the expected shortfall or expected loss values that we see. Okay, what they see is these are actually too high. Okay, when the periods that we have, the historical data periods, these are the historical data periods. Okay, when we are trying to estimate here, these are the historical data. When these have faced with a higher volatility, the VAR estimates are more. Okay, so that's why here you should use the volatility weighted method. Okay, here also they are saying that are seen to be too low when they are facing the low volatility. So you have to use some other methods of this non-parametric, that is a volatility adjusted. Okay, now what happens is these methods are actually not capable of handling this structural shift or regime shift. What we have seen in level 1, the structural shift are, let's say these are the period of volatility and this is a period of another volatility. Let's say this is volatility and this is with time. Okay, so some time have lower volatility, some time have higher volatility. when you're considering the historical data, okay, let's say from here to here, you will take this entire period. You will not be able to structure, okay, so you have to do some more analytics and say that, okay, I want to break this history and break this history. Okay, so you will have this method, it does not automatically help you in segregation of these different regime. Okay, historical data is not right. And what happens is, another problem is historical data is required for longer time period. Okay, so longer time period is required, and that can cover up this entire regime. Secondly, if you want to include in the portfolio a stock which has recently started trading, what will happen is it will not be able to capture that also, because of the because historical data is not available for that. Okay. Now what our thing is that cannot include large impact event. Okay, so it cannot include large impact event, okay, if they did not occur in the sample. Historical data, let's say if there is a no data, let's say we are trying to capture data from 2009. From 2009 to 2012, we did not experience any extreme losses of 15%, 20% like that. Okay, so your non-parametric method will not be able to capture that because we have not seen any large loss data. Right. Again, one more disadvantage is constraint. If let's say in this is one thing, one problem is if you did not have this large loss data, you'll not be able to model. Okay. Another problem will happen if there is large loss in the history. Let's say this is your history, historical data. If you have experienced large losses, which are actually ghost. Okay. So constrained by large losses in the historical data set, and hence what we are saying is well suited to handle extreme. Okay, so here like these are the things, so it's actually handled to it is actually more suitable to handle the extreme data losses rather than the normal losses, especially when you have the data sample size is very less, small or medium. We'll see the next chapter is actually handled on the extreme value theory. So what we are saying is non-parametric method may be useful in extreme value theory, okay, if there are actually large losses.